Okay, that means 2 bits we have to transfer, and the size is 32 bit. 4 bytes of data we are transferring in a 1 bit of transaction. Okay, so and the starting address is 08 or 0C.
So can you share your screen for easier to explain?
Okay, sorry. I didn't share. This was the example yesterday we have taken. Na? So we decide the address boundary based upon the length. What is the length we have decided? So as we know in wrap burst, the possible values of length are 2, 4, 8 and 16. Only these 4 possible values are there. Correct. So whenever we have, let's say, the wrap length of 2, so we just like take the two addresses as the wrap boundary. Like based upon the size, we'll calculate the addresses 0004, and then these two are the upper address and the lower address. Like over here, I have marked. This is the first wrap boundary. This is our second wrap boundary. This is third wrap boundary. This is our fourth wrap boundary. So similarly, if we take the length as 4, so the first 4 addresses, this combines a first wrap boundary. So whenever a address is coming up in, let's say over here, the first address is 04. The first bit is going over here, second, third, and then it will wrap to D4. Other possibility, the first bit starting from 08. So second beat, third beat, fourth beat. If it's starting from over 0C, so it will wrap to 00, 03 and 04. So same way, if we have length as 8, so the first 8 addresses, uh, mm, so the first 8 addresses from, oh shit, save Vinita. Okay. So our first 8 address, this will constitute our a complete first address boundary. Okay, and then from 20 till 3C will be a second address boundary. So we have to calculate the address boundary based upon the length and the address increments based upon the size. Okay. Now let's take a question. Let's say we have a address of starting address as D4, hexadecimal D4. We have the AW size as 2. Okay, and we have the AW length as 16. So just try to solve it. What would be the like from starting address when the address will get wrapped and where will be it wrap? What would be the upper boundary and the lower boundary for this scenario? Okay, everyone just start.
AWLEN count है 15 15 हो गई
Yes, yeah, like it will be 15, na? 15 plus 1, 6, yeah, 16.
16 bits
Hmm.
Starting address D4.
Starting address is D4. Everyone is doing now?
Yes, sir.
You have, yeah, you have to tell me the upper address boundary and the lower address boundary. How the beats are going to be stored, 16 beats.
Uh,
Yeah.
uh, I have the answer that the start address would be C0 and the end the destination address is EC
C0 and
C0.
EC.
Yes.
Okay. Anyone else?
Starting address D4.
Hmm.
EST का क्या है?
Exact address. It's like EF
10 10
10. मतलब what would be the last address? ये नहीं बताओ आप उसका फोर्थ बाइट का एड्रेस नहीं बताना. The last address वो C में ही होगा. FC and upper D0.
ऊपर D0 रहेगा.
D0, E0, F0.
Sorry for the answer that C0 to FC. Sorry,
D0.
Okay.
I
FC.
miss calculation.
Mm-hmm. 16 beats.
16 तो FC से नीचे ही जाएगा.
Huh?
FC से ऊपर जाएगा.
Sir, last address would be FC
Hmm.
and the starting address would be
Starting address will be
C0.
D0.
Sir, C0. According to me, it should be
Okay.
C0.
Same as this one. Hmm. D0 क्या होगा?
अपर बाउंड्री है मेरी 10 है.
Upper boundary is 10.
F
10F.
lower boundary है
10F. And
lower boundary है D0.
D0. Any other possible answer? Nam, Yogesh, which one is correct? Have you calculated, Nam?
This
I don't think C0 is correct. I think from C4.
Okay. Okay. So we just see the starting address. So basically we'll see now the length is 16, correct? So the upper 16 addresses and will create one address boundary, correct? So first address boundary is from 0x00 to 0 cross 3C. That will be your last address. 3C is your last address. Then 0 cross 40 till
7C.
0 cross 80 0
BC.
cross correct. This will be your address boundary and a D4 is lying in this particular segment, correct? So we'll start with the D4 beat and we'll wrap to the FC and then we'll go to wrap boundary to C0, correct? So this will be the correct answer. Okay, now that I think you asked the question how to calculate the wrap.
Yes, sir.
Yeah, so now things are getting clear.
Hi, sir. Can you explain the research address?
What? Sorry.
Can you explain the answer of this? It's,
Could I explain?
how to calculate it?
Okay, so I told you over here now, like when we have to calculate based upon the length, we are calculating the upper and the lower boundary. So length will tell us how many addresses are there within a burst, correct? So based upon that, we are calculating the wrap boundary. So for length 2, if we have the address, we have the addresses 00 and 04. We have taken a size as 2 for all the scenarios for now. So if any of the address is there, so these are the two possible solutions. If the starting address is 00, then our beats are stored in D1 and D2. And if the starting address is 04, it is storing as D1 and it will wrap to 00 because the length is only 2. So the upper two addresses is creating the first boundary, then the next two addresses is creating the second boundary. That's how we are calculating the address boundaries. And there is a specific formula for that. You can see in the specification using the start address, length and size. It's a formula. So using that also you can calculate the upper boundary and the lower boundary. Okay, same way for the length 4, we are picking up the 4 addresses. You can once see the formula and try to calculate with this, and then you can just recollect all these things. Okay.
Yeah, yes, sir.
Okay, so let's take one more example. I think now we just let's say our length is 7, size we change to 3, and the starting address size what we have taken 3, 4, 8. 108 hexadecimal. 0 cross 108. So now you just tell me what would be the upper and the lower address boundary.
One zero zero four zero eight.
Hmm?
100,408.
100
408.
408. Lower is 100.
And 408.
408 कैसा है?
Length of the 8
Hmm. Hmm.
100, 108, 108, 108.
एड्रेस गलत इंक्रीमेंट कर रहा है। एड्रेस गलत इंक्रीमेंट कर रहा है। 108 के बाद क्या आएगा नेक्स्ट एड्रेस?
अच्छा मैंने
lower 100.
इसलिए बहुत बट अपर व्हाट
I
वुड बी
have
द
the answer. Yes, the start is 100 and the
Mm-hmm.
last is 138.
13.
138. Okay. Only man
100.
is
You are giving lecture on next time.
हाँ,
He has an interview on Saturday. Same here. He has 178.
how Huang, like no one else is answering, huh? Any other possible value, or this is the correct one? Can anyone explain like how we get these values? How like what are the all the possible addresses? The first address is 108. Then what is the next address?
The 10C,
10C. The size is Molly size is 3.
sir, it,
Nine. Like what is the next address then? After 108, the data is stored at what address?
इधर उधर निकल जाता हूँ।
Next address is 110.
Okay, 110. Yeah, I know, man. I just want to hear from someone else.
Sorry.
Yeah,
Something.
no issues here. Viet,
Yeah.
so what would be the next address after 110?
118.
Okay, so why you are not answering?
I'm thinking.
Okay, so and after that 118.
120.
Next
128. 130.
138, and after that we'll have 100. Correct? Now everyone got the idea how the address is, yeah, the data is being stored at what address location and how the address is getting wrapped.
बड़े एड्रेसेस में हम लोग लास्ट की दुनिया की
आगे का तो same
डायरेक्ट
रहेगा।
100 से भी शुरू करते हैं
सर लेकिन ये डी और ये तो दोनों ही जीरो करना पड़ेगा।
दोनों जीरो करना पड़ेगा।
ये तो
एलएसबी में एलएसबी से ही हम करेंगे ना मतलब साइज के हिसाब से
आपका 16 बाइट्स मतलब सॉरी लेंथ इज ओनली 16 ना, तो बहुत ज्यादा, और साइज भी कितना ही है।
सर पहले मैं क्या कर रहा था एनर्जी साइड से जीरो करके काउंट कर रहा था कल तक। मैंने ये टीवी को स्टार्ट किया, मुझे लगा ये होगा तो ये टीवी को तो उसके लिए फिर
आप बेसिक स्टार्टिंग से लेके चलो अपना, लाइक 0 0 से एड्रेस सेगमेंट बनाने स्टार्ट कर दो ना। 0 से कहाँ तक जा रहे, 16 बाइट्स कहाँ तक स्टोर, 16 लेंथ कहाँ तक स्टोर होती है, 0 0 से F0 तक हो रही है, तो F0 80 C0 अपने आप सेगमेंट्स बन जाएंगे। जो मेमोरी का आपको स्ट्रक्चर बनाना है, ये अपने माइंड में जितना जल्दी आप इस चीज को बना लोगे ना अकॉर्डिंग टू साइज और लेंथ कि इतना इतना इतने सेगमेंट बन गए, वो अपने आप आपको एड्रेस बाउंड्री कैलकुलेट हो जाएगी। Okay, so I think now we start with the new topics. Okay. Today, what we'll cover? Firstly, we have हाँ एक बार टॉपिक लिख लेते हैं, aligned unaligned address और narrow transfer. Okay, so first we'll see and about the read also. Yeah, कल read response में भी सब नहीं ठीक है. Okay, so we just write our data are ready, are valid, are lost, are response. Okay, so now these are AR. Okay, so yesterday we have seen like for for a complete write burst, we are getting only a single response. Correct. After the end of the transaction, we are getting a single response. But what about the read? How many responses will come over a read? A single response is there, or multiple responses are there? Let's say we have generated address 0 cross 0 0, burst is INCR, size is 2, length is 3. Okay, so our data is started coming, read data, RD1, RD2, RD, RD3, RD4. Correct. Valid IDs have throughout. So when the last will assert,
RD4 sir.
it will be asserted at RD4. And what about the response?
RD4.
after ID4.
Response will be generated at RD4.
Last
Okay. And what about all these 3 beats? What should be the value of response?
0, 0, 0.
So what are the possible values of response? Response signal is of 2 bit, 1 down to 0. Okay. So for 0, 1, 2, 3. 0 means okay, 1 means X okay. Decode वन टू slave होता slave error decode error. So 0 means you are getting a okay response over here as well. So what should be the value of response on these 3? So what would be the value of response for all the read data? Even if it's 0, it will be a okay response. Is this correct?
I think it's correct.
Okay. If it's correct, so why we are getting the response for every beat on a read channel, read data channel? और कैशे प्रेफरेबल वो कल कर लेंगे अगर सर क्वेश्चन भी करेंगे मैं बोल हाँ ये तो बेसिक है. Man, you said like we get the response on every beat. So you know why we are getting the response on every beat?
I think for each bit is a different, is it individually the valid ready answer?
Yeah. Every beat has its own ready valid handshake. That's why this is a
And
one
different
reason.
address,
Hmm?
different address.
Different.
Sorry.
I didn't get the last what you said on last.
Sorry.
Okay.
Just
So,
different from valid ready headset.
mhm. So basically, the main reason being like we only send the starting address in the AXI as we know. So all the address calculation will happen on the slave side. So whenever we are storing all the beats, the address increment will happening on the slave side only. So whenever the slave is returning the data, so this is the data for 0 cross 0 0. This is the data for 0 cross 0 4, 0 cross 0 8, 0 cross 0 C. Correct. So internally it is calculating, slave is calculating these addresses based upon the attributes. So there might be a possibility that we are just crossing some of the address boundaries, or we are accessing some reserved register or a read only register, or maybe we are crossing the slave boundary. So internally slave will provide a response that this particular beat is correctly accessible inside a slave memory, or whatever memory we are accessing inside the slave or a register, that is accessible and it is correct. So in case, let's say we are just accessing a slave which has only two locations. So 08 is, let's say 08 and 0C, these are the reserved addresses. So over here, the response will change to, if we are accessing a reserved location.
रिपोर्ट जब आता है वो रीड ओनली एग्जिस्ट अगर करता है तो फिर
So for the accessing the reserved location, it is quite dependent upon the IP as well, because some of the IP returns a OK response, but nowadays most of the IPs start giving us the slave error. So now we can have the two possible values of response. Okay, so that's why in read data channel and read response channel, so we have the response for every beat of the data. And in write, we have the response only for like for the complete burst, we have a single response.
That's also can be sir okay, in data, right data also.
Right?
For right data, what
Hmm.
kind of response? All the four responses, but at the last, not at the.
So when a OK response can be expected? When all the transactions are correctly going. Okay. Or whenever a exclusive transaction get failed, then we get a OK response. Okay, you can just read the spec as well for when we get the XOK, OK, slave error, decode error. Just to remember, XOK tell us the success of a exclusive transfer. That the exclusive transfer we are accessing, it is correctly passing. Slave error, one of the scenario we have seen when we are accessing a reserved location, or when we are writing to a read-only register, if there will be a case of FIFO overrun or underrun, when the buffer will get overflow, that is one possible scenario, or when we are trying to access a power of slave. So there are multiple scenarios in which a slave error can occur. And what about the decode error? Decode error will be handled basically by the interconnect or knock, because decode error means the address a master is sending that is not lying within the range of the slave. Okay, so let's say the slave boundary is 0 cross 0 0 0 till 0 cross FFF FFF, and the address generated is 1000. So this 1000 is not lying in the slave address range. So knock will not route this particular address to the any of the slave. We have, okay, diagram is not there. Notepad will. Okay, so over here knock will handle it and it will throw the decode error to the master. Any doubt so far about the read response channel, read data channel, and types of error?
No, sir. I think it's okay.
Okay, so we'll see about the narrow transactions. Okay, so what is what is a narrow transaction and how the transfer get affected, how the data beats will get affected based upon the narrow transactions. So what is narrow transaction? Basically, whenever our data width, let's say it's 63, data width is wider than the size. So over here, like we are accessing the 4 bytes, but the data bus is of 8 bytes. So we are not accessing the complete data bus. Then we have to calculate based upon the strobe. Now what is strobe? Strobe will tell you about the active byte lanes. So basically strobe, 1 bit of strobe correspond to 1 byte of data. You're getting, should I write somewhere or you're like noting or you're getting what I'm saying? Everyone,
Yeah, I understand.
you
So in
understand?
this
Yeah,
case,
we.
the stop should be is 40 and 41.
Okay. So like over here in a particular beat, we are accessing 4 byte. So the width of strobe will be 3 down to 0. Okay. Within for every beat we are accessing, we are providing the value of strobe. Over here we are providing, let's say take binary 1111. Again in binary 1111. Okay.
If the right data have the width of 64 bit, I think the stop should be 8 bit. Is it?
Yes, correct. I am telling you with the older example this thing, but now if we have the data width as 64, then it should be of 8 bit. Okay. Now how the narrow transactions are happening? Should I delete this thing? कर दूं delete ना किसी को चाहिए या
Yes, sir.
फिर सेव करके रखिएगा नहीं क्या करना है सेव करके let's take this example with the increment across 10 basic. Okay. Now you just tell me, like we are accessing 4 byte and the data bus width is 64. So what should be the values of strobe over here? Because only 4 bit of strobe should be high. Narrow transactions, like we are accessing some part of the data bus. So strobe की value क्या होगी यहाँ पे? What should be the value of strobe? Hexadecimal में बताना है. 0 है.
I think 6021.
6021.
21.
So that makes only 2 bytes are 2 bytes are, but we have the size is 4 byte.
41.
41. So we can write 0 cross 0f. What about the second beat?
F 0.
Third one? But you're getting कि ये 0f f0 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 कैसे हो रहा है? कैसे हो रहा है?
तो पहले एलएसपी वाले हमारे बिग बस वाला था,
हम्म.
उसमें एलएसपी वाले में हमारा डेटा था ना, एलएसपी वाले जो थे उसमें डेटा हमारा स्ट्रोक की हो रहा था. ये मैं
Okay.
फिर नेक्स्ट टाइम में
I just
लोअर बाइट
change the starting address. Let's say this is my third beat. My starting address is 0 cross 14. Everything is same. Now tell me what would be the value of strobe for D1.
F0 and 0.
Is it correct? The starting address is now 14. Hmm? Or you're saying 0 cross F0? 70. 70 कैसे? 4 बाइट तो एक्टिव चाहिए. पैटर्न क्यों चेंज हो गया?
But why is F0, sir?
F0.
Why?
Why F0? Yeah, that's what I'm asking. Like over here also they said F0, but I just asking like why the
So,
huh?
so why is
Yes,
I think it's 0.
yeah, yeah. I'll explain. First, I'm taking up the possible answers from everyone. Yeah, size is 4 bytes. एक साथ 4 0x14 हाँ हाँ 8 बिट का स्ट्रोब है हमारा 8 बाइट्स हैं 4 बाइट एक्सेस कर रहे हैं हम तो एक साथ बीच की 4 कैसे रहेंगी
तो स्टोर के लिए हमारा एड्रेस मैटर करता है सर. हमें तो सिर्फ नंबर ऑफ बाइट्स से एड्रेस के जो
so basically strobe is telling you what byte is active, but for what address also? Like for this particular address, your data is valid. That particular byte of data is valid data. So we need to take care of the address as well. क्या?
0 से 7 स्टोर होने वाली है।
हाँ,
0 स्टार्टिंग स्टोर उस पे मेरा 0x14 है।
स्ट्रोक पे एड्रेस नहीं है, मतलब स्टार्टिंग एड्रेस इज योर 14, है ना? तो उसके कॉरेस्पॉन्डिंग स्ट्रोक क्या होगा? अब 04 पे हाउ मेनी बाइट्स वी आर राइटिंग? 1 बाइट। सो नेक्स्ट एड्रेस क्या आएगा हमारा?
0
तो 14151617 4 बाइट आपने ये राइट करे। इसमें एक्टिव कौन कौन सी है? वो स्ट्रोक की वैल्यू बता रहा है।
कौन बता रहा है?
अरे डब्ल्यू स्ट्रोक सिग्नल है तो
डेटा भी 64 बिट है ना?
हाँ,
इसमें 0 है तो 4 बाइट
रैप अभी छोड़ते हैं। नहीं, रैप में भी यही रहेगा, है ना? एक
इंक्रीमेंट तो 14 है तो वो इंक्रीमेंट होता चला जाएगा ना, तो 0 f0 0
मैं यहाँ पे बनाता हूँ। हाँ, 5 6 7 8। एक सेकेंड, विल स्टार्ट। हाँ, 1 2 3 4 5 6 7। What is starting address is 0 cross 10? इतनी मेहनत ना मैंने अब तक करी नहीं है जितनी अब कर रहा हूँ। वन ए बोल दो यार कोई। So when we have a 64 bit of this W data and a starting address is 00, first we'll see this particular scenario. Okay, इसमें शेडिंग आती है। So starting address is this one, and we are accessing only 4 byte. So the strobe will be high for only these 4 bit, correct? For remaining 4 bytes, our strobe will be low. This dark one is low, इसको white ही रहने देते हैं. Okay, this correspond to your value of 0 cross 0f, जो हमने that we given a strobe of 0f, correct? But now for the second beat D2, what is the starting address?
18
Why 18?
4 by
You first tell me this is the address 0 cross 10. What is the address for D2 beat? 1. Address for D3?
1
Correct? So for the first beat, when the address is 00, the 4 beats are high. We have the strobe of 0F. At the next transfer, address is 14. So the memory is pointing to address location 14. So the strobe will be 0F0 because it is accessing this part of the memory. Correct? Second, like currently we are talking about this. Okay. So for 10 address, the address line 1 beat is containing 8 bytes, but the valid bytes are 0, 1, 2, and 3. 4, 5, 6 are not valid. Correct. In the next, the memory is pointing to address 14. 14, what would be the address boundary for 14? It will be 10 only. Correct. So it will calculate over here also, it will calculate based upon the boundary. So that's why it is containing it will having the strobe of F0. Now the next address is pointing to 18. So again it will be 0F. Now, now the memory is pointing to address 1C. That's how we get F0. So this second transfer is clear how we are calculating the strobe based upon the 10 address.
Yeah, yes, sir.
Okay. Any doubt, like please just ask. Because it's difficult to explain the way like this. Otherwise, you have to just read the spec. ओके सो यहाँ पे तो नहीं है समझ आया कैसे स्ट्रोक कैलकुलेट हो रहा है now we have changed the address to 14 we'll take the same table I'm pasting over here for now so my starting address is 14 correct so from here we are sending the valid data and the size is 4 byte so this is our valid data and 0210 is not valid first tell me about the addresses of this d1 is 0 cross 14 0 cross correct so first beat we are sending the data of 14 now next address is 18 so we have the active strobe over here and deactive over here so it will be 0 cross f0 0 cross 0 f again 1c is active this is inactive then we have 20.
Hello.
Yes.
For the width of the AXI width of 64 bit, I think that when a thread is not aligned to A coming to the design, it need to align it before do the grind. Like as with D1, D2, D3, and D4, I think it realign to a thread. The first is a thread 0 multiple with 1 0. The first is 1 0, and the second is 1 0. The third is
Okay, you are saying the address it should be 10.
yes. The second is 102.
Second is 10.
Just 10, but it use the stroke to point to where the memory is storing the data.
Hmm.
Is it? That's my thinking.
So basically, the so the size is 4 byte. So these are the addresses like the slave is calculating based upon the size. Correct. When we have the starting address as 14, we have the INCR burst only. Okay, it doesn't have to do with the width of the data over here. There is no relation for that. The address calculation will happen based upon the starting address and the size only. So if we have the starting address as 14, the after 4 bytes only, that is the next location for the slave memory 18, 1C and 20 because we have the INCR burst. Okay, and when we have a wider width of bus, data bus is wider, so we just need to take care of the stroke, like because in the first, like over here, like we have the access from 10 to 17 because like over here, the same way we are calculating the wrap boundary, we have to take care of the basically the address because if it is starting from 00, it is first bit is going to from 00 to 07. Same way it is going from 10 to 17, 18 to 1F. Over here also, when we have a wider, let's say over here we have a data width of 128 bit. Okay, we have just doubled. So it will be like from 102 till 1F. Okay, and still if we are, okay, we'll take an example for 128 bit as well after this. So things will be more clear. But this thing is making like this is clear to you or not?
So I still think that the first transaction should be still is the thread is 10 with the stroke is F0
Mm-hmm.
because it would do a byte write to the memory.
Mm-hmm.
So
But
the thread
after
the thread
what
at the slave, the slave need to calculate the thread.
what you're saying that is for your wrapping bus basically like when we have the aligned and unaligned addresses, so that time we need to take care like if we are generating a unaligned address, but is this 14 is a unaligned address or a aligned address? When a 10 will I got your point, what you're trying to say, but that is the concept of aligned and unaligned. So whenever we are generating a unaligned address, so there are two ways to handle it. First, for a wrapping burst or for a INCR burst, we just generate the aligned address and we take care with the help of stroke. But over here, you just tell me this 14 is a aligned address or a unaligned address. This is basically alignment of the address we check based upon the size. Okay, so if the
Okay.
yeah, so if the address is coming like 151617, then in that case we can say this is an unaligned address, and we can give the address as 14, keeping the strobe value low for rest of the them, like from 10 to 14. Still, we don't generate the address as 10 because we have the AW size as 4 bytes. Okay, we have to take care the width as 4 byte only. It will wrap to the upper boundary only. So if the unaligned address of 15 is generating, so it will wrap to the upper boundary of 14 only, and
Thank
keeping
you.
the
Yeah.
3-bit
Calculate
high
based on
and
the size.
sorry,
Calculate based on the AW size. Yeah.
yes.
Yeah.
So this 14 is an aligned address, so we don't need to give a upper boundary address and keep the store value low. That what you're saying, that is for the unaligned address concept. Zero cross F0, zero F. नहीं मैंने हाँ F0 so this is clear, like how a narrow transaction is happening and how we are identify it based upon the strobe value and how the strobe value calculation is happening. This is actually very important. Like most of the times we'll ask the question how the narrow transactions are happening. So what would be the possible value of strobes? बहुत important है narrow transaction. वो unaligned का concept आ जाएगा.
मास्टर लेकिन मतलब उसको अलाइन करके फिर रैप के लिए भेजता है
अलाइन करके उसका स्ट्रोक वैल्यू को लो करके आगे वाले पे हाई कर देता है.
मतलब वो 15 से 17 तक
स्ट्रोक बन रहेगा, बाकी 5 के लिए 0 रहेगा.
बाइट साइज तो हमारा 4 बाइट्स का है तो फिर एक बाइट तो नेक्स्ट वाले
नहीं, इट्स नॉट. अच्छा, इट्स नॉट नेसेसरी कि आप जो कह रहे हो ना कि साइज 4 बाइट है तो उतना ही डेटा पूरा ट्रांसफर होना चाहिए. वो आपको ये बताता है कि मतलब पूरा डेटा वैलिड नहीं होना चाहिए. वो ये नहीं बता रहा कि पूरा 4 बाइट वैलिड ही होगा. वो बस ये बोल रहा है कि 4 बाइट और 3 लेंथ, तो 4 लेंथ है तो 16 बाइट का डेटा ट्रांसफर होना चाहिए. अब क्या वैलिड है क्या इनवैलिड है उससे कोई फर्क नहीं है.
अगर स्टार्टिंग
1-4 से भेजिए. वो अभी बाद में करेंगे यार, अनलाइन कॉन्सेप्ट का. ओके, आई हैव वन क्वेश्चन ऑन दिस. ठीक है, let's change some parameters. Let's say our W data width is now 128. यहीं से ले लेना. अरे यार स्पेक पढ़ो, पूरी टेबल ऐसे ही दे रखी है. इसका स्नैपशॉट की कोई जरूरत नहीं है. हाँ
बस वही डेटाबेस चेंज करिए.
नहीं नहीं हाँ. Now you just tell the data width is 128. Okay, and I'm just changing the parameter over here. Let's say our starting address is 1C, keeping the INCR burst. Size is also 4 byte. Length is 7. अरे 7 बड़ा हो जाएगा. Keep the length 3. 4. हाँ. So based upon this parameter, the starting address is 1C, INCR burst, size 2, length 3, and our W data width is 127 down to 0, 128 bit. So based upon this, just tell me what should be the strobe values.
The first one is F000.
Just a second, huh? Let me create some space. This one, okay. What would be the width of strobe now?
16 bit. 16.
What are the addresses? Starting address is my 1C.
1C.
This is correct. Addresses.
Correct.
Okay. Now just start telling me about the strobe value.
The first one is F000.
F000.
Yeah. The second is 000F.
Okay. 000F.
000
Enter.
F0.
00F0.
Yeah.
Hmm.
And the final is F00. I mean 0F00.
Okay.
रैप तो नहीं है सर
नहीं.
तो सर 10 एड्रेस तो नहीं आएगा ना
10 एड्रेस का है.
पीछे वाला सर
ये-
जो रीच में कर रहा है सर
हाँ. ये वाला थर्ड है ना. ये पर्टिकुलर ट्रांजेक्शन 000F 000F
ऐसे ही करेंगे
00F0 ये सेकंड सॉल्यूशन आपने दिया. करेक्ट यही बोला ना. यही
Ủa viết sao mà ra được C cái lần cuối cùng vậy? 10, 16 mà. Ủa, sao phải trừ 4 vậy?
रैप एड्रेस में बीट रैप नहीं है
बीट रैप नहीं होती।
मेरी तरह से अगर मॉडल
So for first beat, it will go from 0 cross
1 0. For first beat, 1 C, 0 cross 1 C to 0 cross 1 F.
जो address bound
Okay, 0 cross 1 0 to 0 cross 1 F.
one last.
Right.
Next period.
2 0 to 2 F. 3 0 to 2 F. 3 0 to 2 F.
हाँ तीनों में भी है तीनों में
अच्छा ओके ओके और आगे यूटिलाइज नहीं होती
आगे की क्यों यूटिलाइज नहीं होगी?
बिकॉज 64 बिट डेटा मेमोरी पॉइंटर एक ही
ठीक है ना?
तो 1C से 1F तक स्टोर में रहेगा
हाँ,
ऐसे बाकी
उसके बाद फिर 20 से 24 का,
राइट
24 से 28, 28 से 2C. Okay, so everyone get like how we are getting this store value for the first this 0C, the data bit according to this 16 byte of data bit, we have the address from 10 to 1F. So in this we are having a starting address as 1C. So only the last 4 bytes are active. That's why we have a strobe as F0. Then for the next we have the according to data width we have 20 to 2F, and in that the starting address is 20. So first 4 bytes, after that the next 4 byte and next 4 byte based upon the address. Any doubt like how we are calculating the slope and how these are the narrow transaction basically? Narrow transaction.
The slope also depends on address boundary we figure out, and according to that we see allotting the memory information.
Slope value.
तो ये आर नॉट कंसीडरिंग मतलब 1C से 1F तक या फिर पहले वीक में कितना वैलिड डेटा है और कितना नॉट वैलिड डेटा है
तो कंसीडर करा तो था 4 बाइट का वैलिड डेटा था, 4 बाइट हमने हाई करी है. टोटल ट्रांजैक्शन कितना हो रहा है इसके अंदर?
इसमें
4 into 4 16 बाइट.
दिस इज aligned
This is for aligned
this
address.
is for aligned अगर हमारे पास 1C की जगह 1D तब वो
Now what are okay, so अब aligned and aligned का है कि what's the difference between a aligned address and a unaligned address? Firstly, like in wrapping burst, there is a must case. I think I'll share the spec. It's a must scenario that a wrap burst should generate a aligned address only. कल भी एक मिनट. क्या कह रहा था? Suspect. So for wrapping bus, there is a must scenario that we should generate a aligned address. The start address must be aligned to the size of each transfer. Okay, but in case of INCR, we can have the unaligned addresses. So how we are going to take care for the unaligned address? Like all this thing today we have covered, you can just go through the specification. It is must, like you when you read out all the things are much more clear. See, that's how we have seen the table today. Okay, how the store value is calculating, where the valid data is coming up based upon the data width and based upon your AW size value. Yeah, वही लिटिल इंडियन बिग इंडियन वाला. Confusing. Okay, so over here we can see the unaligned transfer. So there are two possibility a master can do when we have a unaligned transfer. Then it can use the low order address line to signal a unaligned address. Otherwise, that we discussed, it will provide a aligned address and use the byte lane strobe to signal the unaligned address. So over here we have a example. Let's say I'm not creating the table again. So over here, let's see, this is a particular example. We have the transfer size is 32-bit. Okay, we have 5 transfers and the address is 01. So what is happening? It will keeping this the strobe low for the 00 address, and it is transmitting all the data. 5 transfers are happening. Okay, so the starting address is still 01. Okay, same case over here when we have the starting address is 07. It's not like it will generate the starting address as 04. It can keep the starting address as 07. Otherwise, it can keep the starting address as 04 and again keep the store value low.
जो आपने कहा था कि साइज एंड लेंथ के अकॉर्डिंग जरूरी नहीं है कि हर डेटा वैलिडेट हो.
हाँ. Okay, now over here we have a narrow transaction as well as a unaligned address. So now the starting address is 07, the last byte only, and the transfer size is 32-bit increment type. So only the last bit is high and the strobe is low for all from 0 to 6. After that, it is following the same procedure. It's not like for rest of these 3 byte, it has to create a new transaction. It will be a invalid data. Okay. So every time the size into length give you the total number of byte. That total number of byte will tell us about total byte being transferred. It's not necessary all of those bytes are being valid in that transfer. Okay, if the unaligned addresses are there, so there might be possibility the upper addresses, not the possibility, the upper addresses should have the store value as 0. Okay. स्ट्रोक कैलकुलेशन ही करवाएंगे अनअलाइंड में.
पूरे ट्रैकिंग वाला है उनका
कहाँ?
ऊपर
उसने अलाइंड एड्रेस ही जनरेट करा. शो द एग्जांपल ऑफ रैम विद द for wrapping, every time your bus should be aligned, because with the everyone just in the spec there is a formula for upper address boundary and lower address boundary na. Just try to just take a 07 unaligned address and try to calculate the upper and the lower address boundary. You never get the correct address boundary. So that's why we every time for wrapping burst we generate a aligned address.
with respect to lower boundaries to make it aligned.
दोबारा.
जैसे मैंने कोई भी बीच में से अलाइंड एड्रेस होता है और रैपिंग दिया तो फिर मैं सर स्टोर में जो फर्स्ट बिट 0 करूंगा उसको अलाइन बनाने के लिए वो स्टार्ट
नहीं, वो ऑलरेडी अलाइंड है ना, तो हमको नॉट नेसेसरी. जैसे इस एग्जांपल में स्टार्टिंग एड्रेस है 04, दिस इज ऑलरेडी अलाइंड. तो ये हमने जो अभी डिस्कस करा था बेसिक नैरो ट्रांजैक्शन, तो ये अकॉर्डिंग टू नैरो ट्रांजैक्शन हम चल रहे हैं कि स्ट्रोक फर्स्ट बाइट फर्स्ट 4 बाइट के हमारे लो हैं.
अगर 3 होता तो
क्या 3 होता?
इसमें सर स्टार्टिंग एड्रेस 3 होता
तो वो अनअलाइंड एड्रेस होता हमारा.
इसमें सर फिर मैं
रैपिंग बर्स्ट में नहीं है, तो आप या तो उसके अंदर रैपिंग बर्स्ट में स्टार्टिंग एड्रेस 00 दोगे और फिर 3 बाइट को 0 करोगे.
मुझे लोअर बाउंड्री निकालनी है.
हाँ.
एरर में क्या आता है
किसमें?
अगर रैपिंग बर्स्ट दे और
अनअलाइंड दे. हाँ, एरर आएगा.
तो रैपिंग में अलाइन ही होगा वो तो मैं मॉनिटर से एरर मारेंगे ना.
ठीक है. एनी डाउट्स ऑन अलाइंड एंड अनअलाइंड एड्रेस? anyone?
No, sir. We
Okay.
will read the spec at home again and ask you tomorrow.
Yes, sure. You just start reading the spec, that is more important. Okay.
Yes, sir.
Yeah. So now we have 2 more topics. One is ordering and data interleaving. और कौन सा टॉपिक बचा? वो कल करेंगे वो वाला. बफरेबल, कैशेबल और एक्सक्लूसिव ट्रांसफर, ये तो कल कर लेंगे. एक्सक्लूसिव
तो इसे ऐसे हमने यहाँ पे 0 दिया था. अब मेरे को पता है कि जिस पीस का जो प्रॉब्लली होगा वो 04 से स्टार्ट होगा, तो उसके अकॉर्डिंग मैं अपने एड्रेस के जो मैं ब्रैकेट्स काइंड ऑफ बना ली और फिर उसके अकॉर्डिंग स्ट्रोक कैलकुलेशन.
हाँ. मतलब 2 पॉसिबिलिटी
कैलकुलेट करना है. हार्ड मुझे
क्या
डिजिटल टाइमलाइन लेके कैलकुलेट करो तो
साइज के साथ ही हमको करना है ना सिर्फ उसको अलाइन. आपका 07 आ रहा है या फिर कुछ भी ले लो, 8 तो हो गया, 5 आ रहा है और साइज 8 है, तो आपको सीधा वो 0 पे ही जाएगा ना, है ना. साइज 16 है और आपका 313 आ रहा है, आपको पता है फिर से वो 0 पे ही जा रहा है।
0 पे ही जाए।
डाटा की साइज पे भी डिपेंड होगा और उस पर भी
हाँ,
साइज पे
AW साइज पे, डेटा के साइज पे तो फर्दर बीट्स का हमारा डिपेंडेंस है, ठीक है, कि उसका स्टोर वैल्यू कितना बिट का हम पास कर रहे हैं।
लाइन में करने के लिए तो वही है ना, साइज से डिवाइड करके तो
हाँ हाँ हाँ,
नहीं तो मतलब वो फिर जो रिवाइज करना है
डेटा बस के पे
नहीं बाइट
हाँ।
टोटल बाइट है
AW साइज।
तो ये हमेशा
रिमाइंडर के लाइन से
स्टेटमेंट हमेशा पहला
पहला अलाइंड हो सकता है, बाकी सारे अलाइंड ही होंगे। हाँ, क्योंकि वो स्ट्रोब वहाँ पे कैलकुलेट हमने करवा लिया ना, आगे का तो प्रॉपरली जैसे चलाना है वैसे ही चलेगा। Okay, so now we have a topic of ordering, like what should be the order, what should be the order of the transaction being generated. I think we have already discussed on this thing, but we'll go through once again. Okay, so let's say I'm taking for the write address channel, it will same for the read address channel. Now, based upon the ID, so we can order the transaction. So let's say we have the different IDs. So data can come in any order. It's not necessary the data is coming for 1, 2, and 3. It can be in any order. It can be the second transaction can come first. After that, the data for first. After that, 3. Any possible values are possible. But that is the case for AXF 3. Every time, just keep in mind we don't have the WID in AXF 4. Everyone remember this, na? Hello?
Yeah.
Yeah, got it,
Yeah.
sir.
So now if I'm removing this WID, can I change the order of the data being transmitted? I have the AWID and I have BID. I'm generating the AWID as 1, 2, 3. So can I reorder the transaction of on the right data channel?
I think yes.
How? Like now over here, if I'm sending the data transaction of address 2, how we get to know it is corresponding to this AWID2 if, if we don't have this WID signal?
Mình có WD mà.
Okay, so there is no possibility of reordering in the right data channel in AXI4. That is the concept only in the AXI3. So in AXI4, the data should come in the order the addresses are generated. Okay, because it's quite simple. We don't have the WID, so we cannot identify this particular data corresponding to which of the address. So we just keep it very simple, like the first data corresponding to your first address only. After the last is coming, this next byte corresponding to your next. It is in order. The data is in order in AXI4. Okay. But the responses, now the response has the BID, so we can change the order of response. It is possible we can give a response of 2 first, and then we are giving the response of first transaction. But now now in AXI4 is it making any sense? Like we have this AW address, the data is coming in order of the address, but we are just like dating a out of order response. Like first data will complete and it can give the response of the first. Why it is just shuffling the response of transaction? मतलब हमारा 1 से 4 में we don't have WID, so the data is coming in the order of the address. Now the response have the BID, so we can just shuffle the responses. Correct. But why it is required? Because once we have received the data, we can just generate the response and send it back to the master. But channel तो हमारा same ही है.
डिफरेंट है ना ये उसमें इसमें जो होगा अगर इंटरनेट स्लेव्स को भेजा डाटा उसका रिस्पांस
ये तो हमारा एक स्लेव का ही इंटरफेस है ना. एक स्लेव का इंटरफेस पे राइट डेटा चैनल तो सेम ही है. स्लेव शफल तो मतलब कोई इसका रीजन भी है. There is no specific reason, so we can just directly generate the response. It's all the implementation specific on the slave. If it is like even after taking the data, if it is taking time in the processing, and meanwhile the other data is also completed, so it can just generate the response of the second first. Okay, so it's all dependent upon the functionality of the slave.
हाँ, of course, because AID में
BID है.
उससे
हाँ. Okay, so this is about the ordering when we have the different AWID. But now let's say I have generated the same IDs. Now, is it possible to generate the out of order transactions? Like even if we have the WID, if we talk about AXI3 or without AXI3. AXI4 basically, without AXI. Without WID.
not that is in order
So whenever we have the same IDs, so the data and the response, it must be in the order they are coming. Because the response or the data, the slave cannot identify like where the next one. It will always keep the first address in the priority.
WID multiple slaves के लिए generated है. दो slaves के लिए अगर generated है same ID.
अच्छा.
ट्रांजैक्शन हो नहीं सकती है. तो फिर वो जब दोनों slave response करेंगे same ID.
दो स्लेव पे तो ठीक है, सेम आईडी भेज दी.
हाँ, तो फिर वो डॉक्यूमेंट इस मतलब कि वो उसको अलाइन करें.
अलाइन नहीं करे, वो इधर का नॉब उसको इन ऑर्डर ही भेजेगा.
मतलब मास्टर को इन ऑर्डर ही भेजेगा.
हाँ.
वो डिक्लेयर करेगा कि स्लेव 1 पे पहले गई थी या स्लेव 2 पे पहले गई थी.
ठीक है, ये क्वेश्चन
बेसिकली मींस सर डब्ल्यू डेटा है तो डेटा में आईडी जैसे जैसे रही है वैसे वैसे रिस्पांस है. जो रिस्पांस को वाला जो लास्ट एड्रेस वाला वो ऑर्डर में नहीं हो सकता.
अगर हमारी आईडी डिफरेंट है, if we have the different ID, then there is a possibility, then we can change the order of response or data. ठीक है, if we have WID as well. But if we have the same ID for the corresponding addresses, so it should be, everything should be in order. We cannot change the order of transactions.
AWID 1 2 3 की जब भी ऑर्डर नहीं था ना सर.
Because we don't have the WID. I'm talking about AXI4 in that case. AXI3 में हम order change कर सकते हैं. So this ordering is like quite simple. So the things are clear or any doubts are there?
नॉक भी ऐड करता है आईडी कुछ भी सेट करता है वो उसके लिए होता है कि मल्टीपल नॉक्स है तभी करता है. नॉर्मल
बट वो रिमूव भी कर देता है अदर साइड.
हां तो जब वापस करते हैं लेकिन वो सिंगल मास्टर की जरूरत है या
कर भी सकता है. वो स्लेव साइड पे है, इधर से तो उसने जो भेज दिया फर्दर आगे अपेंड कर रहा है या रिमूव कर रहा है, वो स्लेव साइड पे करेगा ना. मास्टर साइड पे थोड़ा ना करेगा. इधर से तो मास्टर जनरेट कर रहा है आईडी, इधर से नॉक जनरेट कर रहा है, तो मॉडिफाई तो स्लेव साइड पे हो रहा है ना हमारा.
मतलब
ये वो सिनेरियो जिसमें दो मास्टर सेम आईडी से भेज रहे हैं नौ जो डिफरेंट आईडी से
हाँ
वो पता लग जाएगा कि नौ को कौन से कौन सा
हाँ
है
हाँ
आईडी से भेज सकते हैं मास्टर
दो मास्टर सेम आईडी से भेज नहीं सकते।
सर
हाँ नॉक फॉर दैट पर्टिकुलर मास्टर इंटरफेस नॉक उसका स्लेव की तरह एक्ट कर रहा है ना, सो वो उसकी ही रिस्पॉन्सिबिलिटी है, वो इन ऑर्डर रिस्पॉन्स भेजे और सब कुछ इन ऑर्डर ही काम करे। हाँ हाँ अब नाउ अगर नॉक अपनी कुछ आईडीज अपेंड कर रहा है, इफ इट इज मॉडिफाइंग द आईडी फील्ड और उसको वो यूनिक जनरेट करवा रहा है, तो फिर वो स्लेव साइड के इंटरफेस पे चेंज कर सकता है ऑर्डरिंग। हाँ हाँ बट ऑन मास्टर साइड वो इन ऑर्डर ही रिस्पॉन्स देगा। करेक्ट। Any doubt on this ordering model?
सर रीड के केस में हमारे पास रीड आईडी होती है और एक रीड मतलब एड्रेस की आईडी होती है और एक डेटा की आईडी होती है।
Understand it's
Okay. Okay, now let's have one question. क्या क्वेश्चन बोला था तुमने अभी? We have a knock. We have one master. We have two slaves. Okay. This knock is generating the transaction. Two transactions are generated, T1 and T2. T1, T2, both having the same ID as 0. Okay, but T1 transaction is going to slave 1, T2 transaction is going to slave 2. Correct? T2 is going over here. Now let's say the response for T2 is completed first and T1 response is completed after the maybe after some clock. So what will happen on this master interface? Does it does knock drive the T2 data first or it will wait for T1? You understand the question?
Can you repeat the question, sir?
Okay, so we have this master, we have this knock, and we have two slaves, S1 and S2. Okay, master is generating two transaction T1 with ID 0, transaction T2 with ID 0, both have the same IDs. Now this T1 transaction is going towards the slave 1 and the T2 transaction is going towards the slave 2. Okay. Now the response of the T2 is completed first. That this transaction is completed. Knock has received the response for this T2 transaction. But after some time, maybe after waiting for 1 microsecond, T1 is generating the response. It is a huge transaction. So now what the knock will do on this master side? Does it wait for completion of T1 or it will transmit the T2 first? It will drive the response for T2 on the master or it will wait for T1 response, then it will drive T2.
I think the knock implementation must be wait T1 for wait for T1 and send T1 to the master
Yes.
before sending T2 to the master.
Correct. Because on the master side interface, we have the two transactions with the same ID. So we must maintain the order of the data as well as the response. So we must wait for the T1 on the master side.
इसमें कुछ नहीं, मतलब नॉट ये जो चीज डिफरेंशिएट करेगा वो एड्रेस के बेसिस पे करेगा फिर, मतलब स्लेव 1 और स्लेव 2 की एड्रेस है उसी के बेसिस पे करेगा।
Okay.
और इस केस में अगर फर्स्ट वाले का रिस्पांस आता ही नहीं है मान लो, तो वो फिर टाइम आउट हो जाएगा।
बट फिर वो सेकंड वाले के साथ क्या करेगा, उसका रिस्पांस भेजेगा नहीं भेजेगा?
नहीं भेजेगा,
तो वो वाला स्लेव टाइम आउट होगा।
पहले वाले का टाइम आउट होगा, सेकंड वाले टाइम आउट होगा भेजेगा।
इसके लिए भी फॉर दिस आल्सो हमारा स्लेव एरर जनरेट होता है रिस्पांस। इफ देयर इज अ टाइम आउट इन स्लेव, तो स्लेव विल जनरेट अ स्लेव एरर रिस्पांस और फिर वो मास्टर को ट्रांसमिट करता है।
फर्स्ट वाले ट्रांजैक्शन के लिए स्लेव हो जाएगा, सेकंड वाले के लिए रिस्पांस हो जाएगा।
स्लेव बिकॉज
कर रहा है ना अपना काम।
नहीं, slave is waiting for the transaction from the knock. The slave, if the timeout is happening on the slave side, so it can generate a error, slave error response. हाँ,
But slave response when you are delayed. That same question.
हाँ.
S1 is delayed.
So the timeout,
हो गया.
हाँ,
उस
so
question को भी भेजना है.
knock will generate the
Slave error.
slave error towards the master
Towards the
side.
master, but slave को नहीं.
टाइम में तो मतलब मास्टर भी होगा ना,
नहीं, slave knock में भी होगा, master में भी होगा, slave में भी होगा.
इसलिए बोलूंगी नॉक के इंटरनल मास्टर में कर रहा है तो वो एक टाइप से स्लेव के लिए मास्टर हो गया। मैं उसी अकॉर्डिंग बोल रहा हूँ कि मेरा टाइमर जो है वो मास्टर में रहना चाहिए या स्लेव में?
Slave में भी हो सकता है. Now slave is waiting for the data. The address is completed, but the data is not being driven by the master. In that case, also the slave can generate the error response.
So वो आगे फिर प्रोपेगेट हो जाएगा नॉक के। तो सर इस वाले केस में जैसे जो उसका रिस्पांस नहीं आएगा तो नॉक का टाइमर टाइम आउट
And it is generating the slave error. Then it is generating the T2 response.
तो सर उस टाइम पे स्लेव कैसा रिस्पांस देगा? स्लेव
error?
के साथ तो रिस्पांस ही नहीं आया।
Slave to time खत्म ही हो गया ना? It is waiting. It is hang. Like with timeout, slave error is generated. Then might be some interrupt is also being generated by the slave as well.
जैसे कैशिकल वगैरह होता है हमारा, उसमें वो होता है ना कि अगर हम रीड कर रहे हैं तो वो उसी से ही द नॉक से ही डायरेक्टली रीड रिस्पांस चला जाएगा।
कैशेबल जो ये वाला इनको भी
ये तो मैं से बोला था कि वो
हाँ वो वहीं की वहीं उठा के भेज देता है। कैशेबल मेमोरी, कैशे इज लाइक आपकी छोटी सी मेमोरी वहाँ पे पड़ी है और चाहे नॉक में हो चाहे मास्टर में हो, अगर उसको कैश में मिल गया वो वहीं की वहीं रिस्पांस देके खत्म कर देगा, स्लेव तक पहुंचेगा ही।
तो उसमें पहुंचता नहीं है ना, बट एक केस ये भी तो होता है ना कि अर्ली रिस्पांस हो रहा है,
अर्ली भी रिस्पांस,
हाँ कि वो पहले रिस्पांस आ गया बट बाद में स्लेव बाद में रिस्पांस भेज रहा है।
हाँ दैट इज डिफरेंट, उसका कैश से कोई लेना देना नहीं।
बोला कि कैश में
वो बफरेबल में भी हो सकता है, कैशेबल में भी हो सकता है।
तो उस केस में अगर
नॉक पहले रिस्पांस कर रहा है और स्लेव के रिस्पांस
It is just sampling the address and data and giving the okay response. Later on, whenever the slave will generate the actual response, it will be routed through the interrupt pair of the knock.
रिस्पांस
अगर हाँ
If there is a okay response, no interrupt will be generated. If there is any kind of error, it will generate a error interrupt from the knock. Okay, so over here some like questions are there now. They are asking like, what if this this T1 transaction is never get completed? Both the complete scenario is the same, but this T1 there is no response is coming out from the slave. Then what will happen?
So it will be hang.
Yes, it will be hanged, but uh, for the hang scenarios, we have the a mechanism of the timeout. So in all master, knock, and slave, we have the timeout feature, which is just waiting for the specific time, like maybe depending upon the IP, like it should wait for this much of microsecond or millisecond. After that, if no response is coming, then it will generate a timeout condition. So now if the slave is not generating the response, so and knock is waiting for the response, so knock will create a timeout. So whenever a timeout condition is there, so on the slave side, now if we see this knock has a slave for this master over here, correct? So this slave uh, will decode like there is a timeout in the knock and it doesn't get the T1 response. So this slave will provide a slave error for this T1 transaction. So whenever there is a timeout on a slave side, a slave error is generated. So once the slave error is being transmitted after the timeout, then this T2 response will be transmitted on the master interface. Okay.
Yeah, okay, sir.
So the timeout is implemented at the slave or at the knock? Is the implementation specific? Tusa?
So the timeout is in all the IPs basically. Like when you have seen the SOC, we have this watchdog timer peripheral and we have the timers. So that timers and watchdog timer are connected to all the IPs. So specific, like based upon their transaction, how long they are taking, we are just giving the particular time. So for all master, for both the slaves and the knock, we have this based upon their specification, we have their timer values. So there might be
Both and
possibility,
knock.
yeah,
Yeah, yeah.
because there might be possibility like the slave is there is a timeout in slave. There might be possibility there is a timeout in master or knock anywhere, because let's say the master has generated the address, but it is not generating the data. Then it will be a timeout on this knock side, correct? But now it has generated the address and data, but knock is not generated the response. So there will be a timeout in the master side. Same way over here as well. So all the blocks have their own timeout feature.
Yes, yes.
Hmm. So ordering is clear, like how the different IDs are there, then we can shuffle the data in AXI3 but not in AXI4. Response can be shuffled anytime. And if the IDs are same, all the things should be in order. That's it. Okay, so the last topic for today, that is write data interleaving. So basically, data interleaving happens with the help of WID. It is termed as write data interleaving only. We cannot interleave the data in the read side. क्यों नहीं कर सकते? Why we call only? Why we have the data interleaving on the write only? Can we have on the read side? Read data channel.
रीड करेंगे तो वो तो एक लाइन ही है
Hmm.
तो ऑर्डर में मिलेगा
Hmm. Every time it has to calculate the address. It has to generate the